Hello friends, this video on continuity and differentiability part 34 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 33. Now we will learn second order derivative. Before we will learn what is second order derivative, let's try to understand why should we learn that. So if my y is equal to fx is my function, my dy by dx is nothing but f dash of x. You find derivative of this, and second order derivative is nothing but f double dash x, and that is nothing but d square y by dx square, and that is nothing but you double differentiate this. So you got dy by dx, you again differentiate this. You differentiate a function twice, you get second derivative. Let me repeat, if y is equal to fx is my function, you differentiate once, you get dy by dx or f dash x. You differentiate twice, you got this, again you differentiate, you get d square y by dx square or f double dash x. That is second order derivation. But why do we need second order derivative? So I know how to find first order derivative now, because I was told that I can use this to find speed of the car, and it's used in the terms of physics and all other places I've used this. But why do we need second order derivative? So let's take the example. Before taking example, we know that the second order derivative is represented by d square y or y double dash. Correct? It is denoted by d square y or y double dash. And as I told, the example is, it is used to find acceleration of car. One of the examples, there are so many examples, but one of them is, it is used to find acceleration of the car. For example, if you have this car, and if this car is moving, it is accelerating, and you want to find what is the acceleration of this car. So if we have a distance time graph in this fashion, for example, it started from t is equal to 0, and we have something like this, it moved like this. Now at this point, for example, t is equal to 2 minutes, let's suppose. I want to find speed. You find slope of this, you get speed. But I want to find acceleration, because speed is nothing but distance by time, and acceleration is nothing but distance by time square. So in this case, I want to find acceleration of this car at t is equal to 2. So what should we do? I have to double differentiate at this point. So if I double differentiate, what I'll get is acceleration. So in this example, if you see, if you are students of physics, you can understand this well. Even if you are not, just try to understand. If I have a distance time graph, this guy gives me distance, so this guy gives me time, and this guy gives distance. Correct? So y-axis gives distance and x-axis gives time. So if I plot this graph in this fashion, the car moves, and based on the time I plotted the point and I got this distance time graph. From this, I want to find acceleration. What I have to do is, at that point, I have to just double differentiate. If I differentiate this function with respect to t once, I'll get x by t. Correct? X by y, sorry, y by x. This is my first differentiation. So if I have x fx, my f dash x is nothing but y by x. And what is y? Y is distance. What is x? X is time. Distance by time is nothing but speed. So if I differentiate once, I get speed. If I double differentiate, this is nothing but y by x square. That is nothing but distance by time square. And what is distance by time square? Acceleration. Thus, if you double differentiate, you get acceleration. If you differentiate, you get speed for a distance time graph. So this is one example where we use second order derivative. We also use, again, in the terms of, in the world of physics, where you want to find the rate at which the nuclear reaction is accelerating or increasing, or all the chemical reaction, the rate at which it's growing, or the population growth you can find. But the rate at which it is growing, the acceleration of the growth of population, those kind of things, you have to use second order derivative. So second order derivative is nothing but where you have to find y by x square kind of funda. You have to find y by x square kind of term, then we have to use second order derivative. That is nothing but you find d by dx, again find d by dx of that, that is second order derivative. and it is represented by f double dash x or y double dash or d square y. Anything is fine. Let's take some hands-on on second order derivative. So let's make y is equal to x square plus 3x plus 2. And I have to find second order derivative for this. The first order derivative will be 2x plus 3. Why? X square becomes 2x, 3x becomes 3 and 2 becomes 0. Y double dash is nothing but derivative of this. You find derivative of 2x becomes 2, 3 becomes 0. So my 2 is my answer. So y double dash is 2. Correct? Very simple. I had y, I found y dash, first derivative. On this guy itself, I found derivative once again, I got second derivative. It's pretty simple actually. Let's take one more example. X cos x is my y. This is the chain rule, u into v. So y dash will be, differentiate this guy, that becomes 1. Let the cos x be constant, plus let the x be constant into, differentiate this guy with respect to x, this becomes minus sin x. Correct? So that is nothing but cos x minus x sin x. So that is my y dash. I have to find second order derivative. So I have to just differentiate this guy once again. So y double dash will be nothing but differentiate cos x. This becomes minus sin x minus x sin x is u into v form. So you first differentiate x with respect to x, becomes 1. This v is again, just keep it like this, minus x, keep it like this only, into derivative of sin x, that is cos x. Correct? So this is nothing but minus 2 sin x plus x cos x. So if you see, my first order derivative was cos x minus x sin x, and second order derivative was minus 2 sin x plus x cos x, and that is my answer. Very simple. You have first order derivative, you find derivative once again, that becomes second order derivative. Let's take one more example, tan inverse x. So I have to find second order derivative of this. First order is very simple. Y is equal to tan inverse x. My y dash is nothing but simple formula 1 plus x square. Very simple. I got my first order. Second order is very simple actually. This is nothing but u by v form. So this is, if it is u by v, y is equal to u by v, y dash is nothing but v square u dash v minus uv dash. Correct? So the same thing happens here, 1 plus x square u whole square, and then you say differentiation of 1, that is d by dx of 1 into 1 plus x square minus 1 into differentiation of 1 plus x square. Correct? So this comes out to be 0 into 1 plus x square, 0 minus this becomes 0 plus 2x, that is 2x by 1 plus x square whole square, and that is my answer, minus 2x by 1 plus x square whole square. Correct? So what we have done, y dash double dash is this value. Very simple to find. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.